All right, so I wanted to take a couple of minutes to go through the answers, how you work through these practice problems, because my goal for this warm up is for you to have practiced and then hear me talk about um, really the Unit 8 concept. So, looking at your derivatives and limits, and really to show you the need for practice and for review. So, first one, pretty standard derivative problem. So you will be given the definition of a derivative on the test. So I will give this to you. You need to know how to apply it. So plugging in the x plus h into the function everywhere you see an x, subtracting the original function, dividing it all by h. From there, it's algebra, right? So be careful to square the x plus h to distribute the negative 4 out. Once you get to this step, you should see things cancel. Now, I want to actually see them cancel. You're proving how this works, so don't make it magical. Make sure that you show what you're doing. You get right here, and you notice that everything has an H. Finally, that H can come out. If we could have plugged in 0 at the beginning, we would, but it makes a 0 in the denominator, which is not okay. So we had to do all this simplifying to get down to the point where we could finally plug in 0. So we put in 0 for h, we get 2x minus 4. That is the equation of our derivative. What does that mean? The derivative gives us the slope at any point on this graph. This original graph was a parabola. I can find the slope at any point on there using the derivative. I can find the slope of any tangent line for that graph using this equation for the derivative. All right, number 2 you did. There's the function. You want to find the equation of the tangent line at x equals 2. So we started exactly the same way, but the algebra here was just harder. So we plug in that x plus h, we subtract the original function, and we divide by h. Good thing, because the 2's cancel right away. When I distribute through that negative sign, the 2's are gone. So here's what I'm left with. And I try to take the limit, but I can't. So if this was, just the problem that you were given, that doesn't mean the limit does not exist. It means you have to work harder for it. So to work harder here looks like using the conjugate. So I use the conjugate because it's going to make things simplify. So I multiply top and bottom by the same expression in the top, but with a plus. And then even though that looks nasty, you just need to keep going. FOIL it out. What do those first terms give you? Root x plus h minus 1 times root x plus h minus 1 is root x plus h minus 1 squared. The squared cancels out the root. You have x plus h minus 1. The inside and the outside terms cancel, so don't even bother with them. Then negative root x minus 1 times root x minus 1 gives you negative x minus 1, and you distribute that sign. All right, so then our x's cancel here and here. Our 1's cancel. We're left with just an h on top, which cancels with that h in the bottom. Okay, so what do I have now? I have 1 over what looks like a really gross denominator. But I'm finally ready to take the limit as h goes to 0. So I plug 0 in for my h. 1 over root x minus 1 plus root x minus 1 gives me 1 over 2 root x minus 1. That is my derivative. That's the function that'll give me the slope at any point. So if the question actually asks, which it does for the equation of the tangent line at x equals 2, I plug 2 into my derivative and I get 1/2. 1/2 then is the slope. I know the 2. How did I get this 3? How do you ever get a y value if you know the x value? You plug into the original function. If you put 2 in the original function, you get square root of 1 plus 2, which is 3. So now I have my slope for my derivative. I have my ordered pair. I plug it into the equation of a line. Y minus y1 equals m times x minus x1. I distribute, I add over. This should have been your final answer. Y equals 1/2 x plus 2. All right, then we took a break from derivatives for a moment to do a pretty quick limit question. So hopefully this is what you had. When you're looking at 3, I like to draw a line, and then I was looking from the left and from the right. From the left, I was at 1. From the right, I was up at 3. That meant that the limit did not exist. This is just like when you're checking for a piecewise function without graphing, you're thinking about the left and the right. Then what is the actual function value is where the point is, which is up at 3. When you repeat the process for 3.5, at this pink here, everything's the same. From the left, from the right, the actual limit and the actual point are all at 3. Our next question asked about continuity. So you did this question, looking for where this could be discontinuous. If you look at this function, it's a piecewise function made up of a line, a point, and a parabola. Those themselves are continuous functions. Continuous just means that you can draw it without picking your pen or pencil up. But because it's a piecewise function, we check where they overlap. That's where the problems can happen. So if we want to know, hey, does this actually match up? We're looking for it to have a limit and to have a value and for those things to be the same. So when we look at the limit of this function as x goes to 6, we look from the left-hand side, which is this less than, we get 42. From the right-hand side is the greater than part. We plug in, we again get 42. So the limit is 42 as x approaches 6. So that's great. It has a limit. But then the actual value, what is f of 6? It's 41. So because these two don't match up, the function is discontinuous at 6. All right, and then the last problem that you did was another pretty serious derivative problem. So this time we had a rational function. So we plug in our x plus h, we subtract the original function, it was negative, so we end up with a plus, divided all by h. This is different here. This is not a radical. I don't use the conjugate. Instead, I want to do a common denominator. So I trade the denominators. I see what happens. I have a negative x and an x cancel, a 2 and a negative 2 cancel. I took my divided by h and I put multiplied by 1 over h, and those h's can cancel. So what do I have now? I have this fraction, and I want to take the limit as h goes to 0. So I plug 0 in for h. I end up getting 1 over x minus 2 squared. That is my derivative. All right, so one more time, what is a derivative? It gives the slope at any point, the slope of the tangent line. So if I want the slope at 3, I plug in 3. I plug in 3, I get 1. So the slope is 1. I have my x value is 3 that I'm given. How do I get this y value? I plugged it in up here. So I plugged in 3, I got 1 over 1 and negative, so I got negative 1. Final step was to write the equation of the line, which gives you y equals x minus 4. So the biggest thing I think on this test is that you need to practice. You're going to have the full class period to take the test. But, a problem like this, if you haven't practiced enough, can take a long time. And you have to finish in your 90 minutes. So you really need to practice to the point where you feel good about it. So you're going to have 2 things to work on the rest of class. The first thing is going to be the assignment that's listed. So in your lesson today, when you look at that, I'm sorry, I was not in the right folder. So in the lesson for today, what you're going to see is that I'm requiring you to finish the Pearson assignment that was the test review. So that's here. So I want you to do the problems that you didn't do for last night's homework and submit work for that. Okay, so that's step 1. So you're required to do that test review. And then what I wanted to show you is the optional test review that I made that I would highly, highly recommend that you do. And it's right here. It's a PDF. And it's not the prettiest thing I've ever made, but I thought if it was me studying for this test, I would want like a nice place where I could go and see a bunch of problems that represent what we did. So that's what I did. I went to the book and I took out the reviews for the chapters that we did, and I marked it up for what you probably want to practice. So you'll see here systems of 2 equations and word problems. You'll see systems of 3 equations. You'll see lots of partial fractions. If that's something you need to practice a bunch, pick a bunch of those and do them until the process seems easy. Systems of nonlinear equations. Then you'll see that was the Chapter 7 review. This is the Chapter 7 test. So narrows it down a bit. I crossed off problems that we didn't do that, so you don't need to worry about those. Hopping into Chapter 8 on matrices, we didn't do a lot of this, so the test is not going to be matrix heavy. I'm really looking for, can you do basic operations, multiply, find inverses, and solve with them? So you'll see practice there, lots of stuff crossed out here, and also the Chapter 8 practice test. And then Chapter 11, what our warm-up today focused on. Chapter 11 goes over, we did everything in Chapter 11. So tons of great problems on limits from a graph, on finding limits of an equation, on continuity, and then on derivatives. And then there is the practice test. After all of that are all of the answers. So I also took the answers, brought them together, and circled the ones that would apply to the work you actually did. So required is to finish the Pearson work, but I think really what you need to do is finish that now in class, or today, and then use the rest of your time preparing, leading up to the test, doing the practice here that you need to practice in order to really have the content down, to make sure that these are processes that you understand. There shouldn't be any surprises on the test. If you practiced enough, it should seem pretty straightforward, because I think the math there is hard enough that I really just want you to be able to do it. All right. So go ahead, head to Pearson, do that work, reach out if you have any questions, but make sure that you're practicing so that you can finish strong.